Hi, in this video we're going to talk about function introspection. Now in general, introspection is simply the act of examining your code, analyzing your code using code, right? So you're using code to look at the code that you've written. Maybe you want to know, some information about a particular object or maybe about a function, right? And in this case, we're going to look at function introspection. So remember that functions are first-class objects. In other words, they have attributes. Remember, attributes is basically a blanket term that covers things like properties and methods. And we've seen some already. We've seen that the function has a dunder doc attribute, also has a dunder annotations attribute, right? Doc contains the doc strings, annotations is a dictionary that contains the annotations for the parameters and return value of the function. We can also attach our own attributes. So for example, if we define this method myfunc this way, we can now say myfunc.category equals math. We've just created an attribute, in this case a property called category with a value that has a string. Right? And we can do the same thing here with subcategory, and we can do many other things. We can attach, objects, other functions, other objects, anything else we want. And we can then return that. We can then get that value back by just using myfunc.category, and that's just going to return whatever's stored in there. In this case, math. So we'll print math. If we print that, we'll print arithmetic. So functions are first-class objects. They have attributes, right? They have properties and methods. So we can look at all the different attributes that are available on a function by using this dir method, this dir method. Well, it's a built-in function that, given an object as an argument, will return a list of valid attributes for that object, in particular a function. For example, we can call dir of myfunc, the one that we just created, and we'll see it has a bunch of stuff in here. We'll look at some of these attributes. For example, the dunder annotations is there, the dunder doc is there as well, and you'll notice that the two that we created, right, category and subcategory, are in that list as well. But there's some others as well, like KW defaults and name and code defaults. We'll take a look at those in more detail. So let's look at the first three. Name, dunder name. Well, that actually is just the name of the function. So if you've got a function, let's say you've got a variable that has a function assigned to it, and you want to know, well, what's the name of that function, right, in your code? Now, you know the name of the variable when you're looking at it, but how would you show that on the screen? How would you display that in the output, right? Well, you would just call the dunder name attribute of the function. You would retrieve it that way. What about the default values? Remember, we can create default values for parameters on functions. Well, we can use the dunder defaults. That will be a tuple containing the positional parameter defaults. And we have KW defaults, which does the same thing, but for the keyword only arguments. And that will be a dictionary. So let's look at an example of that. Suppose we've got this function. We've got three positionals, with two of them having default values, and then we have two keyword only, with one of them with a default value. We can look at the dunder name, which is going to return the string myfunc, right? That's the name of the function. We can look at dunder defaults, which is going to return the tuple 2, 3. Those are the two over here. So you'll notice that it doesn't give us like a none, right? It doesn't tell us that there was another parameter or argument here that didn't have a default value. So when you're looking at matching up the default values with the parameter names, you kind of have to go and work your way from right to left, okay? And then the same thing with KW defaults. It works the same way, but it's a dictionary in this case, which gives us the keyword name and the default value that's associated with it. Let's look at the dunder code attribute. So if we have this function defined here, then we can look at the dunder code attribute, which is going to return an object, right? It's going to return an object of type code, an instance of a code object. And that object itself has various properties, which include the following. We have val names, co-val names, which are going to be the parameter and local variable names. So in this case, the parameter names would be a, b, args, kw args, and the locals would be I. We created I. B is not a local, well, B is a local variable, but it's not considered a, it's the same as this variable here, right? This B is this parameter. So if we call myfunc dunder code dot coval names, that's how we would access it, we would get this tuple, a, b, args, and quargs, and then I. So note that the parameter names come first, and then they're followed by the remaining local variable names. We can also look at underscore arg count. That will return the number of parameters. So it's going to count the number of parameters. But you'll notice if we make this call, we get a value of 2 back. It does not include the star args and the star quargs. So when you do your count, it doesn't include these guys over here. It will include any positionals or any keyword only arguments, but it doesn't include those two over here. So it means that you can now start looking at a function, and you can start looking at its name, its parameters, its default values, and you may want to do something with that. But it's a little tricky, right? Remember that here we're getting the arg count, which doesn't include the args and the star quargs. We have this list, but it includes the local variables. We have the default values, but of course, if the parameter doesn't have a default value, it just doesn't show up. So, and then we have to, match from right to left. So there's some intricacies in all this. So the easiest is actually to use another module that's built in called the inspect module. And to do that, you have to import the inspect module. But once you've done that, there's a slew of methods and functions that you can use in this inspect module. Let's look at some. So we've got the is method, is function, and is routine. Those functions are all related, and there's many others. We'll look at some of them again, in more detail later in this video. But let's do a little segue to talk about the difference between a function and a method. I've been using the terms very loosely throughout, and I'll probably continue using them loosely. But in Python, there is a basic difference between a function and a method. They're not really the same thing. They look the same, they're kind of defined almost the same way, but they're not quite the same. And we'll look at that again in a little bit more detail when we look at callables in general. But functions and methods are both things that can be called. There's a difference though. Remember that classes and objects have attributes. And attributes is, it's an object, it's something that is bound to the class or to the object. So for example, an attribute that is callable, that is called a method. Let's look at an example. So we have some module, and inside this module, here's our code. We have def myfunc. So here we've created a function using this def, right? Now we've created a class, def myClass. And inside this class, we've created a function. We've used this def keyword again. The only difference is that this function here, which uses self, is an instance method. It's an instance function, right? So it's a function, it's a property of my class. It's an attribute that is bound to the instance of my class. It's not bound to my class. And we'll get into more detail on that in the object-oriented section, but you have class methods, you have instance methods, you have static methods. In this case, we're looking at an instance method. This means that this is a method that is bound to instances of the object. In order to call this function here, we'll have to declare first my object being an instance of my class, and then we could say my object dot func, right? And then func is going to receive my object in this first parameter here. So this is a method that is bound to the instance of my class. So technically it's not a function, it's a method. Whereas this thing over here is a function. It's not bound to an object or to a class. It's just kind of off by itself in the module. So that is considered a function, not a method. Right? Same thing with lambdas. Lambdas defined, let's say, at the module or whatever, would be, functions. They would not be methods. So func is bound to my object, an instance of my class. So if we ask is function, from the inspect module, right, we can call is function of my func, it's going to return true because it is a function. On the other hand, if we call is method, that's going to return false because it is not a method. If we call is function on my object.func, we'll get false because it's not a function, it's a method, right? If we call isMethod, we get true. So you have this way of being able to distinguish between, bound and unbound callables, essentially. If you don't care, you can also use isRoutine. isRoutine will basically look at whether it's a function or a method and then return whatever that is. So isRoutine for my func will return true, and for my object.func will also return true. So it kind of depends on what you want to do. So those are three kind of interesting calls in the inspect module. But now let's continue. We can recover the source code of our functions and methods. We can actually look at the source code in code of a piece of code that we've written. It's kind of weird, but we can do that. And we can do that using the getSource function in the inspect module. So we just pass in the function we're interested in, or the method, right, whatever callable, and we'll get some information back. In this case, we'll get a string containing the entire def statement, right? So for example, you could write a piece of code that looks at a function that's been defined in a module somewhere and prints that out to the screen. It might be very useful for documentation purposes. Now we can also find out in which module the function was created, and Python will attempt to do that. The get module function is going to try and tell you where was this function created, my func. So for example, if we're running inside the module main, like we had in the previous example, we'd get this module and then done the main. This is where it was created. On the other hand, you can also use a built-in method like print. It will tell you, well, it comes from the module built-ins, which is a built-in module. Same thing, you can look at the sign function in the math module. When you do that, it will tell you sign was defined in the module math, which is also a built-in module. What about function comments? So we've talked about docstrings in the past, but take a look at this example here. We have comments that we scatter throughout our code. And you can see that these two comments here really have something to do with my func, right? To do implement the function, because I have a pass in here, so I'm putting a to do as a reminder for myself that I need to come back to this later on. Maybe some additional notes, and then I've got the function definition, and then I've got comments inside. This is not a docstring, this is just a comment, right? And then I've just got pass. I didn't do anything in the function itself. Well, you can use the getComments function, and you pass in my func, and you get back these two comments here. You get back basically any comments that are immediately preceding the definition of the function. So in this case, we have the to-do implement function and the pound, /n, right, new line, and then the next comment, some additional notes. You'll notice that it doesn't include this comment here, and it doesn't include this comment over here inside the function. Now, why is this interesting? Well, many IDEs today support to-do comments. So if you actually write your comment, like in PyCharm, for example, you can write a pound to-do above some function, and then you put in some comment or whatever. The IDE itself has a location where you can go and look at all the to-do statements, all the to-do comments, I should say, not statements, right, that you've created in your code, and it will tell you which function it's associated with. How does it do that? Well, it uses the getComments. It works the same way. So we can do that ourselves. If you want to implement something that goes through your code and brings back a list of all the to-dos that have to be done, then you can do that using code introspection, using the inspect module and the getComments. So for example, if you're doing, trying to do builds maybe, and you want to write a Python script that's going to go through all the code as it pulls it out of a repo and checks to make sure that there are no to-dos left, that's one way of doing it. Or maybe you work in a team and people put to-dos in there, and you get your version of the code, you update your local repo, and you need to know, okay, what do I need to do? What do I need to work on? Maybe you do that using the to-dos, and you can certainly basically use getComments, for the different functions to see which ones have to-dos associated with them. So there's kinds of things like that you could do. Now, just note, these are not the same thing as docstrings, okay? The docstring for my func, so my func dot dunderdoc would be empty in this case because there is no docstring. It is a comment, not a docstring. Okay, now let's look at the signatures of functions and callables in general. And we can do that using the signature function in the inspect module. We just pass in the callable, and we will get an object back, which will be an instance of the signature class. Now, it's an object, so it contains attributes, one of which is the parameters attribute, which is an interesting one. It's essentially a dictionary of parameter names, which are the keys, and then metadata about the parameters, which will be in the values. So the values are going to be objects themselves. So the keys will be the parameter name, and then the values will be objects, and they'll have attributes. Some of the common ones are name, default, annotation, and kind. So name is just the name of the attribute, of the parameter. So it will actually be the same as the key in this case. Default, well, if this parameter has a default value, it will show up here, or it will be none if it doesn't have any. Annotation, again, if the parameter has an annotation, we'll see that there. And kind. Kind is the type of parameter. That's kind of an interesting one. Remember when we define functions, we have different types of parameters. We have positional parameters. We have those star and star star parameters. We have keyword only parameters. Well, that's what kind will tell us. It will tell us what it is. Positional or keyword is the one that we've been talking about as positionals. Remember that when we define a positional parameter in a function, when we call the function, we have a choice of either passing in a positional argument or naming the argument using the keyword, right? So they're positional or keyword. Those are the traditional positional parameters that we've been defining in this course so far. And those are called positional or keyword in kind. They're identified by that. This is just a value, right? Positional or keyword is actually an integer value, but it has this string name, right? It has this variable name in the inspect module. You also have var positional. That's like the star args. You also have keyword only. Those are the arguments, the parameters that come after the star, right? They become keyword only. You have to specify them using a keyword. We've seen that before as well. And then you have the var keyword, which is the star star. Okay, so those are the four types of parameters, and we've seen those before. We've worked with them before. But there is, however, another one, the positional only. These are parameters that you can only pass by position. In other words, you cannot say, well, I'm going to use a keyword to pass that in. It will refuse to accept a positional only parameter using a named argument. Now, we haven't seen this so far, and the reason we haven't seen this so far is that we actually can't do this ourselves. So in Python, we don't have a way of creating positional only parameters in our functions and callables. Python, on the other hand, internally does. And so there are some functions which have that, and we'll see that in the code. When we take a look at that, I'll show you some examples. So the callable signatures, let's take a look at now a more concrete example. Suppose we've got this function, def_my_func, and here we have a bunch of parameters, right? We have A and B, which are the positionals. A has an annotation, B has an annotation and a default value. Star args, right, with an annotation, and then keyword only arguments, KW1 and 2. KW2 has a default, and then the star star quarks with an annotation. And then a dark string, and then something or other that the method does. For param in inspect.signature, right, so we're going to first look at the signature of my func, then we're going to look at the parameters of that signature, and then we're going to look at the values. Right? We know what the keys are, that's just the parameter names, but we have that in the value as well. So in this case, we're just going to iterate the values of the parameters dictionary. And we're just going to print this out. We'll print name, param.name. So that will give us the name of the parameter, the default value of the parameter, if any, the annotation of the parameter, if any, and then the kind of that parameter. So let's switch to some code and actually see this in action. It'll be much clearer when we do so. Thanks for watching, and I'll see you in a bit.